Go Zips.
Hey, I have one.
Creighton.
I haven't going past.
Creighton going down.
I gave Akron 2 wins.
Ooh, I got him going to the Final Four, of course. Yeah, why would I not? What number is
Do you have
this?
them winning?
Huh?
Do you have them winning?
Do I have them winning? No.
If you send them to the Final Four, you gotta commit to the bid.
No.
And just
Yeah. Come on, man. We're here to
Huh?
subscribe.
I got Kentucky winning.
Respectable.
63, given the following data. So I'm going to have to do a little bit of writing here, which I'm so good at. I have 2H2 gas, states matter, plus carbon solid yields CH4 gas. Delta G is negative 51 kilojoules. That's my first one. And I am trying to end up with CH4 gas plus 2O2 gas yields CO2 gas plus 2H2O liquid. Do you guys remember Hess's law? Mm-hmm. That's all this is. That's all this is. So, this first one, what do I need to do this first one? You got to flip it. So, I'm going to rewrite that as, I shouldn't have even written that, but I just wanted to show you. CH4 gas goes to 2H2 gas plus carbon solid. If I flip it, my delta G becomes a positive 51 kilojoules. CH4, CH4. The next one is my 2O2. I would save that one. I would go to my CO2 because I only have CO2 in the third one. Agreed? Yes? So the third one I'm going to leave as is. So the third one I have carbon solid plus O2 gas yields CO2 gas. And that delta G was negative 394. Negative 394 kilojoules. So CO2, CO2. And then I need to get H2O on the right. I have 2H2O in the second one. Agreed? Yes? In the second reaction? And it is on the right. So I'm going to leave that one. And I'm going to make that 2H2 gas plus O2 gas yields 2H2O liquid. And that gets a delta G of negative 474 kilojoules. So I have my 2H2O liquid, 2H2O liquid. What about my 2O2? Well, what's 1O2 plus 1O2? 2. My carbon cancels out, my H2 cancels out. Add them up. So when I add those up, I have 51 plus negative 394 plus negative 474. That gives me negative 817 kilojoules per mole. Let's see if that's right. 63. Yep, that's right. So that was just Hess's law.
Can you explain 56?
56.
It's asking about thermal, kinematic, and thermodynamic.
Okay, so 56 is interesting because it's saying, is it under thermodynamic? Is high temperature needed for thermodynamic or kinetic reasons? What is that saying? So thermodynamic reasons means for heat reasons. Do I need to put heat in? Kinetic reasons means, are the particles lining up? Right? Remember we talked about particles lining up and we said the hotter it is, the faster they're moving, the more chance of them hitting each other? Right? So on this for 56, the first thing that I did is I solved for delta S. So on 56, I got a positive For my delta, for my delta S, for my entropy, I got positive. Because I form more moles of gas. I also know if my delta S is positive on 56, that means that my delta G is going to be negative or spontaneous at all temperatures. So this is going to be spontaneous at every single temperature. And on this one, I have to, the 100 degrees Celsius, I'm putting that in. When I solve for my delta H, the delta H ends up being positive or endothermic, right? The delta H ends up being positive. So I already have delta H as a product, as a reactant. So do I need to put in more heat to make that move to the right? No. So then that means you have to put more heat in just to make the particles line up. Therefore, it's under kinetic control. So that was kind of a weird.
Can you explain that again? You guys did.
It's endothermic, which means I would write heat as a reactant.
Yes.
So I already have heat as a reactant, pushing it to the right, making more of the HCN. So do I need to put more heat in for thermodynamic reasons? No, it's endothermic. Do I need to put it in to make them line up? That's why. For the kinetic reasons. Are the molecules lining up? That was a tricky one. But that's it for 56. Anything else? Did we do 63? We did that.
We do one of them on 93.
One of them on 93?
Yeah. It's with a basic reaction.
Yeah, let's do it. 93.
Can you do just the first one?
Just the first one? Oh, wait, is this the next? This is page 163 now?
Yeah.
Okay. So we're going to page 163. 93. We're doing the first one? That's what you guys want to do? Okay. So on 93, I am given, this is 93A, Al solid plus MnO4 minus Aq yields MnO2 plus AlOH4 negative. AQ. Step one, split into two reactions, right? So the first one is going to be MnO4 minus goes to MnO2. Second one is going to be Al solid is going to AlOH4, which is a minus. To figure out which one's reduced, which one's oxidized, I would do this one, right? Because this is 0, right? This has to be what? +3. So in order to become more positive, what did it have to do with electrons?
Keep it away.
I lost electrons. So this is oxidation. This is reduction. Cool so far. First step, balance everything except for H and O. 1 Mn, 1 Mn, 1 Al, 1 Al. Check. What's the next step?
Balance O's.
Balance O's by adding
Water.
H2O. So I got 4 O's here. I got 2 O's here. So I have to add what on this side? Plus 2 H2O. I've got 4 O's here, so I have to add on this side? Plus 4 H2O. Next step, balance your H's by adding H. 4 H's here, plus 4 H plus. 8 H's here, 4 H's here, so what do I have to add on this side? Plus 4 H plus. Look good so far? Yes? Next step is balance my electrons. By doing what? By adding electrons. So on this side, I have a +3. On this side, I have, that's great. Right there is good. Thank you so much. This side, I've got a +3. This side, I got 0. So which side do I have to add electrons on?
Left.
Left. How many?
3.
Plus 3 electrons. This side I got 0. This side I have -1. Remember, that was just the charge of aluminum. This whole thing is -1. This side I got -1. This side I have a positive 3.
So you add 2.
I have positive 4, -1. That makes it a positive 3.
So add 3.
So I have to
Add 3.
add 3 electrons. Well, that's sweet, because my electrons are balanced, right? So now I have to rewrite it. So we're going to rewrite it. So I have 4. Oh, actually, my H plus is gone, right? That's gone. So that is going to give me 4H2O, 2H2O. So the left side's going to have 2H2O plus MnO4 minus plus Al solid yields MnO2 plus AlOH4 minus plus, or is that it?
That's it.
That's it. Let's see if we got it. What chapter is this?
4.
Chapter 4.
That sounds like a good
3, 4, 93.
No, I just opened my page can't see that.
A. So we have 2H2O plus MnO4 minus plus Al yields MnO2 plus AlOH4. Is this basic?
Yes.
How do we know? There's no H plus, right? Just the fact that there's no H plus is basic, is already enough reason for it to be basic. So as long as there's not H plus, it's basic. So that was 93A.
Can you explain how do you set up the equation for B? Because it's just Cl2 on the left side.
93B.
Yeah. It's just Cl2 on the left side.
So you would write Cl2 goes to OCl, and you would write Cl2 goes to Cl minus.
Okay. That's all.
Yep. So those are your half fractions. Okay. So that should